So my screen recorder's acting up today, so we might end up with two videos. So I'm just going to prompt you guys on that to start. So the photosynthesis lab is your last lab that's going to be handed in for the course. It is another gizmo, so you should be familiar with this process for getting more than the 5 minutes that you would get if you just link to here. So make sure that you use your login. You've got my code. You should be able to get into there. So let's look at the lab itself. Some of the things that we're going to be talking about vocabulary-wise: carbon dioxide, chlorophyll, glucose, photosynthesis. And before you get started, you should have gone through the content area for activity 15. So some of these things are going to be in the forefront of your mind. And it says what? To survive, what gas do we need to breathe in? So think about what you breathe in, and then where is that gas produced? Obviously, quite quickly below in the content, you're going to find out the answers to that. So the gizmo itself: during photosynthesis, plants use the energy of light to produce glucose, which is also C6H12O6 from carbon dioxide and water. Glucose is what? It's a simple sugar that plants use for energy and as a building block for larger molecules. A byproduct of photosynthesis is oxygen. So out of this process, you end up producing a bunch of oxygen. Plants use some of the oxygen, but most of it is released. So down here, it's actually got the, too far. So if you scroll a little bit more through the lab before you start, you'll see the formula for photosynthesis. So basically, carbon dioxide, water, light energy will go to give you glucose and oxygen. So that is the formula for photosynthesis. So let's look here. Observe the left pane closely. What do you think the bubbles are? So you don't really see a ton of it when you first come in. So I've already launched this gizmo, so just make sure that you launch it. But see, when you move it a tiny bit, those are the bubbles they're talking about. So what is that? Chances are it is probably what? So think about what's getting produced. Next part, select the bar chart. So you have to use this part up here. So select the bar chart on the graph. I'm just going to slide this over. Notice the oxygen production bar. So that's right here. Move the light intensity slider back and forth. How does light intensity affect oxygen production? So that's here. So we're going to move light intensity, but we're going to look at what's happening to the oxygen production. So if light intensity goes down, what happens to oxygen? Does it go up or down? You would make a statement about that. What happens when light intensity reaches a certain point? So we can get the oxygen to increase to a certain point, and then what happens? If the light intensity increases, does it have an impact on oxygen flow, or does it only have an impact until a certain point? So those are the things that you're going to comment on here. Experiment with the vertical temperature slider. So the upper left and the CO2 slider. So let's do the temperature first. So we're looking again at oxygen and what happens when the temperature goes up. So you'll see temperature here too. What happens when the temperature goes down? Is there a certain point where the impact, you kind of have to think about when temperature is high, when temperature is low, and then make a statement about that here. Okay. So next part. How does the CO2 level affect oxygen production? So let's just put our temperature around here. How does the carbon dioxide level affect the oxygen production? So that's here. So what happens if we start playing with this one? What do we see? there's not much happening in that area. But then what happens when we get down here as the CO2 levels, so the carbon dioxide starts to drop? So what's happening to the oxygen levels? And when you're doing this, you want to look at kind of what are the values where you see an impact in the change. So you're going to fiddle with that. So make a statement there about that. Use these values in your statement. So when you think about, once it goes past a certain point, does it have any impact on oxygen flow? Once it is under a certain point, what's the impact that it has? So your statement should almost be twofold. How does oxygen production relate to the rate of photosynthesis? So think about down here. How does the oxygen production relate to photosynthesis? So if you have a high level of oxygen production, what does that mean for your rate of photosynthesis? If you have a low level of oxygen production, what does that mean for your rate of photosynthesis? So you would make a statement there about that. So question. So here's the investigation that you're going to do. What are the ideal conditions for photosynthesis? So I actually kind of liked playing with this one too. So you'll see the levels will go up to a certain point, and really you're just wanting to watch the oxygen flow here. So the table, the bar chart's nice, but I also liked this one for specific numbers too. Same thing when you're playing with the CO2 and you're looking at what's happening with the oxygen. Right? So you're looking at oxygen flow with respect to that. So I would use those two pieces when you're kind of fooling around with this part. So in the gizmo, what light intensity and CO2 level do you think will maximize the rate of photosynthesis? So you're going to try to come up with those values, and then you are going to this is your hypothesis first, and then you're going to experiment. So what are the ideal conditions for photosynthesis with regards to temperature? So when you're just varying the temperature and you're looking at the oxygen flow, thinking about when are you maximizing oxygen flow? That would be the best condition. Same thing with light intensity. What values are maximizing oxygen flow is what you would put here. CO2 levels, same thing. Where are you getting that maximum value? And this is what you're recording over here. So around, I'm just going to use the number that we see right now, but 440 parts per million. Until when are we getting the maximum oxygen flow? So you would tell me that. And then, and then you're going to try to figure out the maximum oxygen production that you can get overall. So, and you're going to put that there. Okay. And to get the value for it, let's just look. Yeah. So it's going to be in milliliters per hour. So make sure you use your units over there. Same thing with temperature. Make sure you have your degrees Celsius. Make sure that you have your percents for light intensity as well as your parts per million for the CO2. Okay, so then what's the next part? Think and discuss. So think about the process of finding the ideal conditions. Why would it be hard to find the ideal light intensity if the temperature were very hot or very cold? So you're going to tell me why. And then why would it be hard to find the ideal CO2 level if the light intensity was very low? So you're going to answer those two questions. So that is your final experiment. In the assignment area, you're going to see the rubric is already attached to the Dropbox. So when you're finished, make sure you submit that into me for assessment.